So let's now talk about password hash attacks. So there are two types of hash attack. One is password hashes and other is password cracking. So let's first talk about password hashes. So a cryptographic hash function is a one-way function that implements a algorithm and also given a arbitrary block of data. Then returns a fixed size bit string called a hash value or message digest. One of the most important uses of cryptographic hash function is their application in password verification. Most systems that uses a password authentication mechanism need to store this password locally on the machine rather than storing password in a clear text. So modern authentication mechanism usually store them as hashes to improve the security. This is true for operating system and also for like network hardware and etc. This means that during the authentication process, the password presented by the user is hashed and compared with the previously stored message that digest. So password cracking. So in cryptanalysis, password cracking is the process of recovering the clear text passphrase, giving it to store the hash. One of the hash type is known, and a common approach to password cracking is to simulate the authenticated process by repeatedly trying and guessing the password and comparing the newly generated digest with a stolen or dumped hash. Identifying the exact type of hash without having further information about the program or mechanism that generated it can be very challenging and sometimes even near impossible. A list of common hashes that you can use for references when trying for identify a password hash can be found on the OpenWAL website. There are three main hash properties that you should pay attention to. Like first one is the length of the hash, which is each hash function has a specific output length. Then second is the character set used in the hash, and the third is any special character that may be present in the hash. So several password cracking programs such as John the Ripper apply the pattern matching feature on a given hash to guess the algorithm that used. However, these techniques works on generic hashes only. So these tools that tries to accomplish the task is called hash identifier. So on your Kali Linux machine, just type hash identifier and it will check the hashes. As you can see, you can check the possible hashes like MD4, MD5 and RIPE-ND and all of those, and also a lot of other these. So you can check all of those hash identifier using Kali Linux machine and using the hash identifier command tool. Very simple. Then let's talk about John the Ripper. So once you retrieve password hashes from a target system, you will want to try cracking them, so you can make use of the clear text value for the further attack. One of the most popular tools and the important tools for cracking password is John the Ripper. So John supports the dozen of password format and is always under the constant development. So running John in brute force mode is as simple as passing the file name containing your password hashes on the command line. So first, just simple John. John means John the Ripper. So John the Ripper's command tool is just simple John, and then this is the address, and then this is the password dump. So as you can see in this, the John recognize the hash type correctly and set out to crack it. A brute force attack such as this, however, this will take a long time, and as an alternative we can pass the word list. So this is the word list parameter that John will use for saving the time, because this will take a lot of time. So if any password remain to be cracked, we can just try to apply the John's word mangling tool, which is the rule parameter. So this is the rule parameter. So in order to crack Linux hashes with John the Ripper, you need to first use the unhashes. So sorry, you need to use the unhashes now. You need to use the unshadow. So unshadow is a utility that combines the password and shadow file from the compromised system. So as you can see, this will combine. So we can take the unshadow file to pass it to the John as we normally would, and this would so this is the so this will normally it will pass it to the John the Ripper, and normally it would crack the password hash. So now this will load up. So as you can see, John the Ripper detected the type, which is the SHA-512, and also detected the option that instead, and also this is the one password hash. So it detected all of those using a simple John the Ripper tool using Kali Linux. So let's now talk about rainbow tables. Because it tries all the possible plain text one by one, a traditional brute force cracker is usually too time consuming, and it is also very time consuming to break complex password. So the idea behind time memory trade-off is to perform all cracking computation in advance and store the result in a binary database or rainbow table. So rainbow table is a file basically. So it takes a lot of time to pre-compute these tables, but once pre-computation is finished, a time memory trade-off cracker can be 100 of times faster than a traditional brute force cracker. So to increase the difficulty in password cracking, passwords are often used with a random value that being sent before the hash being used. So the value is known as the salt, as we all know, and it's a value so which should be unique for each password and is stored together with the hash in the database or a file to be used for authentication process. The primary intent of solving is to increase the infeasibility of rainbow tables that attacks and that could otherwise to be used for greatly and improve the efficiency of cracking the hashed password addresses or databases. Passing the hash into the windows. So cracking password hashes can be very time consuming and it is often not feasible. A different approach of making use of the dump hashes without cracking them has been around since like 1997, I guess. The technique known as pass the hash allows the attacker to authenticate to a remote target by using a value combination of username and NTLM/LM hashes rather than using a clear text password. So this is possible because NTLM password hashes are not being salted and remain static between session and computer. So which combination of username and password is the same. So let's talk about a scenario. So an organization uses a disk imaging technology within its network or otherwise has a local administrative users using a multiple computer. So a vulnerability on one of those computers has provided us with the system privileges, through which we dump the local M or NTLM hashes. We copy the local administrator NTLM hash and use this to discover hash instead of password, which a patched version of PTH WinXC to gain a shell on a defined machine, which is the same local administrator or password combination. So we begin by first environment called SMB hash and containing the password that we like to use for authentication. So we can use the PTH, then after that we can use the PTH WinXC tool to authenticate using the password hash and gain a remote command from to a target machine. So this is the remote command and this is the target machine and this is the command. So after that, as you can see, hash pass is substituting, and as you can see, it will do all of those in a simple command, and also it will remotely command the target machine. So that's all for this.